So this is about trigonometry, and maybe the first thing I'll do is remind you of some basic things about trigonometry. So if I have a circle, all trigonometry is all based on this circle of radius 1 and centered at the origin. And so if this is an angle of theta up from the x-axis, then the coordinates of this point are cosine theta and sine theta. And so that leads right away to some trig identities, which you know very well, but I'm going to put them up here because we'll use them over and over again today. Remember the convention, sine squared of theta secretly means sine of theta quantity squared. It would be more sensible to write a parenthesis around the sine of theta and then say you square that. But everybody in the world puts the 2 up there over the sine, and so I'll do that too. So that follows just because the circle has radius 1, but then there are some other identities too, which I think you remember. I'll write them down here. Cosine of 2 theta, there's this double angle formula that says cosine of 2 theta is cosine squared of theta minus the sine squared of theta. And there's also the double angle formula for the sine of 2 theta. Remember what that says? 2 sine theta cosine theta. Now, I'm going to use these trig identities, and I'm going to use them in a slightly different way, and so I'd like to pay a little more attention to this one and get a different way of writing this one out. So this is actually the half angle formula. And that says I'm going to try to express the cosine of theta in terms of the cosine of 2 theta. So if I know the cosine of 2 theta, I want to try to express the cosine of theta in terms of it. Yeah, well, I'll start with the cosine of 2 theta and play with that. Okay, well, we know what this is. It's cosine squared theta minus the sine squared of theta. But we also know what the sine squared of theta is in terms of the cosine. So I can eliminate the sine squared from this picture. So this is equal to the cosine squared of theta minus the quantity 1 minus cosine squared of theta. I put in what sine squared is in terms of cosine squared. And so that's twice the cosine squared of theta minus 1. There's this cosine squared, which gets a plus sign because of these 2 minus signs. And there's the one that was there before, so altogether there are 2 of them. I want to isolate what cosine is, or rather what cosine squared is. So let's solve for that. So I'll put the 1 on the other side, and I get 1 plus cosine of 2 theta. And then I want to divide by this 2, and so that puts a 2 in this denominator here. So some people call that the half angle formula. It's a way of, what it really is for us is it's a way of eliminating powers from sines and cosines. I've gotten rid of this square at the expense of putting in a 2 theta here. We'll use that. And similarly, same calculation shows that the sine squared of theta is 1 minus cosine of 2 theta divided by 2. Same cosine in that formula also, but it has a minus sign for the sine squared. Okay, so that's my little review of trig identities that we'll make use of as this lecture goes on.